Hello, dear students. Welcome to the YouTube channel and welcome to this playlist in which we are discussing about the protection against over voltages. Initially, we have discussed about what is an over voltage, what is voltage surge, and what are the consequences of voltage surge, how it can affect my power system, and how we can tame it. We have also seen what are the phenomena which causes over voltages. We have seen internal phenomena and external phenomena, or rather we can call internal causes and external causes. After that, we have seen what is lightning. We have seen the science behind the formation of lightning. We have seen how the lightning gets formed, what is the mechanism of lightning discharge. Then we have seen different types of lightning in the very previous class. We have seen direct and indirect lightning stroke, and we have studied about the effects of lightning discharge that can take place in power system. After knowing that the effect of lightning discharge in power system can be very dangerous to the different equipments of power system, we have discussed about how we can protect different equipments of power system with the help of different type of mechanisms. We have discussed earthing screens, we have discussed overhead ground wires, and in the last scenario we have discussed about the lightning arrestor. So continuing that discussion, now we are going to discuss about what are the different types of lightning arrestors and how we can uh, use the surge absorbers. So if you have not checked out the previous videos of this playlist, by the way, this playlist is very small and it will be you can get over it very quickly. So you can check out those videos and you can just go and explore it. If you have understood those videos, then it is more beneficial for you to understand this. And even though if you haven't, it will be this video will also be a separate video, so you will be able to grasp things as well. So if you haven't checked out, the link will be flashing on the top right hand side corner of your screens. Click on it and see that video. If you have already checked out, let's move forward. So about the different types of lightning arrestors. So the lightning arrestors are very much common in use in power systems, right? And even though these lightning arrestors are different in constructions, they work on the same principle, right? So it provides a low resistance path for the surges to the ground, and that is the working in short. So there are basically five types of lightning arrestor. First one is called rod gap arrestor, second one is horn gap arrestor, third one is called multi gap arrestor, fourth one is called expulsion type lightning arrestor, and last one is the valve type lightning arrestor. Now let's discuss each of them in detail. So the first one is the rod gap arrestor. It is a very simple type of diverter, and it consists of 1.5 centimeter rod. As you can see here, this is the rod. So it is 1.5 centimeter rod, and it bends at right angles with the gap in between. You can see it is bending on a right angle within a gap in between. That gap is called rod gap. So one rod is connected to the line circuit and the other one is connected to the earth. Now the distance between gap and insulator must not be less than the one third of the gap length, so that the arc may not reach the insulator and damage it. Generally, the gap length is so adjusted that the breakdown should occur at only 80% of the spark over voltage, in order to avoid the cascading of very steep wavefront across the insulators. So the strings of the insulators for an overhead line on bushing transformers, bushing of transformers, has frequently a rod gap across it. So now you know where it is used, right? And by the way, this one, the figure that you are observing is the same as well. It is same the rod gap uh, across the bushing of my transformer. So under the normal operating conditions, the gap will remain non-conducting, and on occurrence of high voltage surge on my line, the gap sparks over and the surge current will be conducted to the earth. And in this way, the excess charge on the line due to the surge will harmlessly conduct to the earth. Now, what are the limitations of this rod gap arrestor? So first one, once the surge is over, the arc in the gap is maintained by the normal supply voltage, and because of that, short circuit, the probability of short circuit is pretty high. So that the second point is the rod may melt or get damaged due to excessive heat produced in the arc. Basically, it is a rod, metal rod, so it may melt or get damaged, right? Then the rod gap arrestor, as it is an open arrestor, it will be heavily affected by the climatic conditions like rain or humidity or temperature or snow, anything. And also because it is an open field, the polarity of the surge will also affect the performance of this arrestor. So due to this limitations, rod gap arrestor is only used as a backup protection in case of main arrestors, or when the main arrestors are getting maintained. So that was the rod gap arrestor. Now let's see the horn gap arrestor. And you might ask that why is it called horn gap arrestor? So see, this this gap, this horns between the gap, because of this uh, horn like model, it's called horn gap arrestor. Basically, it consists of two horns, like two, not exactly a horn, two horn shaped metal rods. Yeah, we named them A, metal rod A, and metal rod B here, which is separated by a small air gap, you can see. And that air gap is increasing as we go deep through this gap. The horns are so constructed that the distance between them gradually increases towards the top as shown. And as the distance is increasing, then the gap is more. These horns are mounted on the porcelain insulators, and one end of the horn is connected to the line through resistance R and choke coil L, while the other end is normally grounded, as you can see here. Resistor, choke coil, other one is grounded, right? So the resistance R will be helping in limiting the flow current to a small value. So the chalk coil is designed that way that it offers small reactance at normal power frequency but very high reactance to the transient frequency. Thus, the choke does not allow the transient to enter the apertures, and hence it protects it. This gap between the horns is adjusted to the normal supply voltage, and if it is not enough to the cause an arc, the gap between the horns is so adjusted that the normal supply voltage is not enough to cause an arc across the gap. Okay, so what happens under the normal conditions is the gap is not conducting, and hence normal supply voltage is insufficient to initiate the arc between the gap. Now when over voltages uh, take place, or when the over voltages occur, the spark over will take place across the small gap, this small gap called G. The spark over will take place over here. The heated air around the arc and the magnetic effect on the arc causes the arc to travel up to the gap, and this arc will move progressively into the position 1, 2 and 3. This three positions you can see here, 1, 2 and 3, are not just normal numbers, they are um, different positions for movement of the arc. And at some position of the arc, uh, for the most of the times that position is position 3, the distance may be too great for the voltage to maintain the arc, and because of that Consequently, the arc will be extinguished, and the excess charge on the line is thus conducted through the arrestor to the ground. Now let's see what are the advantages of horn gap arrestor. First one, it is self-cleaning, as the arc is extinguishing after the third point, and therefore this type of arrestor does not cause any short circuiting of the system after the surge is over, as in the case of this rod gap, right? Rod gap, same thing does not have takes place in the rod gap arrestor, but this is self-cleaning. Series resistance will help the uh, flow of the current, right? It will limit the follow current to very small value. Now what are the limitations of this? So bridging of gap by some external agency, like it can be a board, anything, it can render the device useless, right? If this gap is gets bridged, if a board is sitting over here, right? So this is a big limitation of horn gap arrestor. The second point, the setting of the horn gap is likely to change due to corrosion or pitting, and this adversary effect is very effective on the performance of the arrestor itself. So you have to take care of corrosion as well. The time of operation is comparatively long, like around 3 seconds. So if your equipment cannot withstand that amount of current for 3 seconds, then this is not for that equipment. Horn gap arrestor is not for that. So in the view of very short operating time of the modern progressive gear of feeders, this is very small time. And because of these limitations, this type of arrestor is not reliable and can only be used as a second feeder or second line of defense, like just like rod gap arrestor. Now let's see the third one, the multi gap arrestor. And what multi gap arrestor has to say, you will see this one is the see in the figure that this is the multi gap arrestor. As you can see, it is consisting of series of metallic cylinders insulated from one another and separated by small intervals of air gaps. And this metallic cylinders are made of normally some alloy material, normally some zinc alloys. So the first cylinder, as you can see here, the cylinder A in this series is connected to the line, and the and the other to the ground through a series resistance. You can see this as point starters if you have studied back in the day when you were in the previous to previous semesters. So you can think of this in that way. So it is connected to the line and the other ground through a series resistance. The series resistance is limiting my power arc, and by the inclusion of series resistance, the degree of protection against the traveling waves is reduced very much. So in order to overcome this difficulty, we have inserted some other gaps, like gap B, gap C, right? So these gaps are shunted by a resistance. So under normal conditions, the point B is at the earth potential, and the normal supply voltages are again unable to break down the series gap. So on the occurrence of an overvoltage, the breakdown of series gap A to B will take place, and the heavy current after breakdown will choose the straight through path to earth via the shunted gaps B and C instead of alternative path through the shunt resistance. So when the surge is over, the arc B and C to go out, and any power current flowing through the surge is limited by the two resistances, the shunt resistance and series resistance, which are not which are in series. If you can see, which are in series now, right? So these two resistors do the job for you. Then you can say that the current the current is too small to maintain the arc in the gap A and B, and normal conditions are restored. So such arrestor can be employed when system voltage does not exceed 33 kV, like for low voltage systems. Then we have expulsion type arrestor, and this type of arrestor is so called protected tube and is commonly used on system operating at voltages up to 33 kV again. So you can see the expulsion type arrestor here. So in the first image on the left hand side, it is showing essential part of an expulsion type of lightning arrestor. So it essentially consists of a rod gap A dash in the series. As you can see, this is the rod gap A dash, and the second gap enclosed within the fiber tube. You can see the fiber tube here, and here we are having this internal gap. So the gap in the fiber tube is formed by two electrodes, pretty much clear here. The upper electrode is connected to the rod gap and the lower electrode to the earth. So you can see this is the lower electrode, it is going through the earth, and this is the upper electrode, right? And one expulsion arrestor is placed under each line conductor. So one expulsion arrestor is placed under each line conductor. As you can see in the second figure on the on the right hand side, it is showing the installation of expulsion arrestor on the overhead line. So whenever the over voltages condition takes place on the line, the series gap A dash is spanned and an arc is struck between the electrodes in the tube. So the heat of the arc vaporizes the heat of the arc vaporizes some of the fiber of tube walls, resulting in the production of neutral gases. So in the extremely short time duration, the gas will build up high pressure and it expelled through the lower electrodes within the hollow. Right? Lower electrode is hollow, so it will expel through the lower electrode. Now, as the gas is leaving the tube violently, it will carry away the ionized air around the arc, and because of this ionized air, it will deionize the effect, right? And that effect is generally so strong that arc goes out and the out at a current zero, and it will not be re-established at all. Now it may sound like a little bit tricky, but once you read it, you will get the hold of it. Now, what are the advantages of it? First one, they are not very expensive, they are very cheap. Second one, they are improved form of rod gap arrestors. As you can see, we are having two different type of rod gaps, as they block the flow of the frequency follow currents, and they can also be easily uh, installable. You can install them very easily. Then what are the limitations of these? So these type of arrestor can perform only limited number of operations, as during each operation some of the fiber material is used, and you cannot mount this type of arrestor in the enclosed equipment because of the discharge of gases during the operation, right? So it is not mountable, and because of the poor voltage to current characteristics of this arrestor, it is not suited for the protection of expensive equipments. So if you are having some expensive equipments, then you might don't want to use it because it's not that safe, so you might don't want to use it. Now the fifth and the final type of lightning arrestor is the valve type arrestor. Valve type arrestor incorporates non-linear resistors and are excessively used on the systems operating at high voltages. So there is only one type of lightning arrestor to use for the for high voltages, so that is valve type arrestor. Others are for low voltages. So now let's see the valve type arrestor. See this figure on the left hand side. It is showing various parts of a valve type arrestor. Basically, it is consisting of two assemblies. First one is the series spark gaps. You can see spark gaps here, the series spark gap. And second one consists of non-linear resistor discs, which is normally made of metrocell or thyroid, and they are connected in series. So we can see this non-linear resistance resistors as well, resistor discs here as well. So the non-linear elements are connected in the series with the spark gap, as you can see here, as you can see here, and both the assemblies are accommodated in the tight porcelain container. So this one is the actually porcelain housing or porcelain container, and both of the containments are kept inside. So when the spark gap is a multiple assembly, and it consists of number of identical spark gaps in the series. So each gap will consist of two electrodes with a fixed gap spacing, and the voltage distribution across the gap is linearized by means of additional resistance elements, which is basically also called grading resistance. If you are familiar with the concept of grading resistance, it will be cakewalk for you. If you are not, then you can see in the second image here, spark gap and grading resistance, both of them given here. So basically the voltage distribution across the gap is linearized by the means of this uh, extra resistance elements across throughout my whole gap. The spacing of this series gap is such that it will withstand normal circuit voltage. But again, in the situation of over voltage, it will cause the gap to break down, and it will cause the surge current to ground via non-linear resistors. Now non-linear resistor discs, they are made up of inorganic compound like thyrite and metasoil, as I've discussed earlier. These discs are connected in series, and the non-linear resistors have the property of offering a high resistance to a flow when normal system voltage is applied, but low resistance to the flow of a high surge current. You can see it in another way, like when the resistance of this non-linear element decreases, the current through them will increase, or vice versa, right? Now how does it work? So under the normal conditions, the normal system voltage is of course insufficient to cause the breakdown of the air gap assembly. But whenever the over voltages are applied, the breakdown of series spark gap will take place, and the surge current will be conducted to the earth via non-linear resistors. Now, as the magnitude of this surge current is very large, the non-linear element will offer very low resistance to the passage of surge, right? And because of that, the result will be the surge will rapidly go to the earth instead of being sent back over the line. And once it's gone, when the surge is over, the non-linear resistor assume high resistance to stop the flow of the current. So pretty much simple. Now what are the advantages of valve type arrestor? First one, they provide very effective protection. That's why we use them for the high voltage protection. Second, they operate very rapidly, and it takes less than a second to um, to protect the circuit or to protect your equipment, and its impulse ratio is practically unit, right? Basically, if you don't know about the impulse ratio is basically a ratio of breakdown voltage under the surge conditions to the breakdown voltage under the low frequency conditions. And it is as better if you want better operation, the impulse ratio should be close to unity. Now what are the limitations? So it has so less amount of limitations. The first one is They may fail to check the surges of very steep wavefront from reaching the terminal apertures. Like that calls for this calls for additional step to check steep fronted waves. So it cannot check for steep fronted waves at all. Secondly, their performance is adversely affected by the entry of moisture into the enclosure. Just like any other lightning arrestor, it will get affected by the moisture or weather conditions. And because of this, the requirement of effective sealing of the enclosure at all times uh, is must. Now where these type different type of lightning arrestors are used, so according to their applications, the valve type arrestors are classified in different types. It can be classified in the line type and station type. The station type arrestors are generally used for the protection of important equipments in power station operating at voltage up to 220 kV or higher. And the line type arrestors are also used for the station handling, but only up to 66 kVs. So these were the types of arrestors. Now let's see the surge absorber. You know, the traveling waves set up on the transmission lines by the surge may reach the terminal apertures, and it can cause the damage to it. The amount of damage caused is not only depends on the amplitude of the surge, but it also depends upon the steepness of the wavefront. Just we discuss something that we just discussed a minute ago. So the steeper the wavefront of the surge, the more the damage which caused to the equipment. And in order to reduce the steepness of this wavefront of the surge, we use surge absorber. So if you want to define a surge absorber, how will you define it? So surge absorber is basically a protective device which reduces the steepness of the wavefront of the surge by absorbing the surge energy. Although both surge diverter and surge diverter is basically your lightning arrestor. So lightning arrestor and surge absorber both eliminate the surges. The manner in which it is done is completely different in both of these devices. What diverter do? The surge diverter diverts the surge to the earth, but the surge absorber does not do that. Surge absorber absorbs the surge energy. Let's see a few of the cases of the surge absorber or surge absorbing the energy. Let's say a condenser connected between the line and earth can act as a surge absorber. Now see this, the image on the left side. It is showing how a capacitor can act as a surge absorber to protect the transformer winding. Since the reactance of the condenser is inversely proportional to the frequency, it will be low at a high frequency and high at low frequency. Now we all know the surges are always on a high frequency, so the capacitor will act as a short circuit and passes them directly to the earth. However, for power frequency, the reactance of the capacitor is very high and practically no current will flow to the ground. Right? There is another type of surge absorber as well. It consists of a parallel combination of choke and resistance, which are connected in series. As you can see here, we are having a choke and resistor connected in the series with the line. Now the choke will offer high reactance to the surge frequency. Basically, if you remember the formula, XL is equal to 2 pi FL. The surges are therefore forced to flow through the resistance R, where they are dissipated. Now see this image. We are going to discuss something about Ferranti surge. This image here, it is showing another type of surge absorber. It is Ferranti surge absorber. Basically, it consists of an air core inductor connected in series with the line. An air core inductor. It might be new for some of you, but air core inductors do exist. If you have studied in detail about the type of inductors in the third or fourth semester, you would know that an air core inductor is used in the surge absorbers. So here we are having an air core inductor connected in the series with the line. The inductor is surrounded by the insulator from an earth metallic sheet called dissipator, and this what can you call let's call it arrangement. This arrangement is equivalent to the transformer with short circuited secondary. So the inductor forms the primary forms the primary, whereas the dissipator forms the uh, short circuited secondary. The energy of the surge is used up in the format of heat generated in the dissipator because of the transformer action. And this type of surge absorber is mainly used for the protection of transformers only. So in both of these images, you can see the schematic diagram of 66 kV Faraday surge absorber on the left hand side, and on the right hand side you can see the equivalent circuit of the 66 kV Faraday surge absorber. So we will keep this class till here. In the next class we will be starting a new lesson, or a new topic, new subject, new chapter. So if you have any doubts, any queries, anything you have, feedback or anything for me, feel free to mention them in the comment section below. I will try to answer them as soon as possible and as many as possible. Thank you very much for listening. I will be seeing you next time.